You've done the work. Your MCP server is authenticated, OAuth is configured, you've scoped which tools each persona can call, enabled read-only mode, and turned on audit logging. By every infrastructure measure, your AI context layer is governed. Then, someone asks your Claude workspace what Q4 revenue was by region. They asked the same question in the Databricks Genie space your analytics team set up last month. They get two different numbers. Both calls authenticated cleanly. Both users had exactly the right permissions. The logs show nothing wrong. But the business is now operating with two different versions of financial truth, one per AI integration, and neither agent flagged the contradiction. That's not a security failure. That's a governance failure. And the reason it happened is that governing MCP has almost nothing to do with access control. It has everything to do with the quality of the context those servers are serving. Most teams are solving the first problem and leaving the second one entirely unaddressed. We've watched data teams spend weeks hardening their MCP infrastructure, locking down OAuth scopes, configuring tool allow lists, writing run books for access review, and ship an AI layer where two agents still disagree on the definition of a basic business metric. The access controls are airtight. The context underneath them is not. That gap is what this argument is about. The dominant view of MCP governance is an infrastructure view, and it makes sense. MCP looks like an API. It has endpoints, it has authentication flows, it has scope permissions. When a new protocol arrives that connects AI agents to enterprise data, the natural instinct of every security architect and platform engineer is to ask, who can reach this, what can they do with it, and how do we audit it? That instinct isn't wrong. The Model Context Protocol specification itself is primarily a transport and authentication document. Anthropic, OpenAI, and the major AI tool vendors have published OAuth flows and token scoping guidance. The community forums where MCP governance gets discussed are full of questions about certificate management, read-only versus read-write modes, and per-tool allow listing. The conversation has the shape of every API governance conversation that came before it, because MCP looks, from the outside, like an API. The infrastructure view also has genuine accomplishments to its name. Per tenant deployment isolation, structured audit logging, per persona tool scoping. These controls matter. An MCP server with no access control isn't just a governance problem. It's a security incident waiting to happen. The practitioner who has built this infrastructure layer has done something real and necessary. The problem isn't that this view is wrong. The problem is that it's incomplete in a specific way. And the incompleteness is invisible until agents start giving different answers to the same question. Here's the exact mechanism by which infrastructure-only MCP governance fails. An MCP server doesn't serve data. It serves context about data. Descriptions of tables, definitions of business terms, certifications that mark a data set as trusted, ownership records that identify who's responsible for an asset, lineage relationships that show where a number came from. When an AI agent queries an MCP server and asks which revenue table should I use for the Q4 regional breakdown, the server doesn't return rows. It returns the metadata that lets the agent reason about which rows to trust. That metadata is only as good as the people and systems that maintain it. And in most organizations, catalog metadata is treated as documentation, written when an asset is created, updated when someone remembers to update it, and largely ignored in between. A table description written 18 months ago, before a schema migration, still reads as authoritative. A dataset certified by a data steward who left the organization 6 months ago still shows a green checkmark. A glossary term that the finance team quietly redefined in January still carries its old meaning in the catalog entries linked to it. Infrastructure governance can't catch any of this. The OAuth flow succeeds. The tool call completes. The audit log shows a clean transaction. The agent returns a confident answer grounded in stale, inconsistent context. and the organization has no signal that anything went wrong. Now, scale this across multiple MCP deployments. An engineering team configures one MCP server for Cursor. The analytics team connects a different instance to Databricks Genie. The data product team wires a third to a Claude workspace for the finance function. Each team makes local decisions: which assets to surface, which definitions to use, which business rules to encode. These decisions live in YAML files, system prompts, and repository configurations. There's no shared governance layer watching for divergence. 6 months later, active customer means something slightly different in each of these three integrations. The engineering agent uses the definition that was current when the team set up their deployment. The analytics agent uses a newer version that was updated after a product change. The finance agent uses a definition that was customized by someone in that team to match a specific reporting requirement. 3 MCP servers, 3 versions of the same business concept. 3 AI agents that'll each give a consistent answer within their own context, and contradictory answers when a business leader compares them. The security logs show nothing wrong. Every call was authorized. Every user had the right permissions. The governance failure happened entirely at the semantic layer, which the access control model was never designed to see. The deepest failure mode is the subtlest one. An organization that's done everything right on the infrastructure side can still deploy an AI agent that is confidently and systematically wrong, and they'd have no mechanism to detect it because the failure mode isn't a security violation. It's a data quality problem wearing a successfully authenticated connection. Here's the better mental model. Governing what AI agents can access is the infrastructure problem. Governing what AI agents actually know, the definitions they reason from, the certifications that mark data as trusted, the lineage that shows what changed upstream, that's the data governance problem. Every organization building on MCP needs to solve both. Most are only solving one. Putting it more precisely, the quality of an AI agent's reasoning is bounded above by the quality of the context it receives. Access control determines who can reach the context. Metadata quality determines whether the context is worth reaching. These are separate layers. They're independently governed, and conflating them produces exactly the failure modes described before. Well-secured agents that give confidently wrong answers. Think about the difference between a library's security system and its cataloging system. A library can have state-of-the-art access controls, badge readers, camera systems, role-based entry, and simultaneously have a catalog that's 18 months out of date, with books misfiled, descriptions that no longer match the current edition, and no indication of which sources are authoritative on a given subject. The access controls work perfectly. The library is nearly useless for research, though. The two systems serve different functions, and one can't substitute for the other. An MCP server is the access control system for an organization's business context. The catalog it queries is the cataloging system. Governing one without the other leaves you with a well-secured entrance to a library where the books are misfiled and the card catalog is stale. Adopting this reframe has a real cost. Access control, it's a one-time engineering problem. Teams configure it, test it, and maintain it on a regular review cycle. Metadata quality is an ongoing operational commitment. Descriptions go stale. Certifications expire. Owners leave. Glossary terms evolve. The new mental model requires treating catalog metadata not as documentation that gets written once, but as a living dependency of production AI systems, something that has an owner, a maintenance obligation, and a quality standard that teams are accountable for. That's harder than configuring OAuth. It requires governance investment, not just engineering investment, but it's the investment that determines whether your AI agents reason correctly. The most direct evidence for this reframe comes from how MCP servers actually score and rank context when an agent queries them. When a data agent asks an MCP connected catalog, which revenue table should I use for the Q4 regional breakdown? The server doesn't return all revenue tables equally. It runs a scoring function. Semantic relevance, how well the table's description matches, does it have a README, and linked glossary terms that match the question. That's what determines what surfaces first. Trust signals, whether the table is certified, whether it has an owner, whether its glossary terms are linked, break ties between equally relevant results. Usage and popularity signals surface the tables that practitioners actually rely on in production. This scoring mechanism is the direct connection between catalog governance and agent output quality, made explicit and measurable. A table with a current description, a certification, a named owner, and linked glossary terms scores higher than an equally relevant table with none of those attributes. The Atlan MCP documentation makes this explicit. Enrichment is the single biggest lever an organization controls over search quality. An agent querying a sparse catalog doesn't just get fewer results, it gets noisier results, where the most authoritative tables are indistinguishable from the least authoritative ones. Every investment in catalog enrichment is, simultaneously, an investment in MCP governance. Certifying a dataset isn't just a documentation decision. It's a signal that an AI agent will use to determine which source to trust when two tables actually appear equally relevant. Writing a description that reflects how the table is actually used, not just what it's named, isn't just good housekeeping. It's the mechanism by which an agent learns to route queries correctly. These are governance decisions with direct, measurable consequences for AI output quality. The second piece of evidence is structural. Software engineering teams learned this lesson about code a long time ago. If two teams maintain separate copies of the same library, the copies drift. Not through negligence, through normal, well-intentioned local decision making. The solution wasn't to audit each copy separately, it was to establish shared libraries governed from a single canonical source, so a change propagates everywhere rather than forking into local variations. Business context in AI systems has the same structure. When each MCP connected agent encodes its own version of active customer or net revenue, the definitions drift through exactly the same mechanism. Normal, well-intentioned local decisions made without awareness of what the other integrations are doing. The governance solution is the same, a single canonical context layer that every agent reads from, where a change to a definition propagates to every consumer simultaneously. Atlan's Context Engineering Studio is one operational example of this architecture, a versioned context repository that functions the way a Git repository functions for code. Every change is tracked, every deployment is a version snapshot, and every MCP-compatible agent reads from the same governed source rather than from locally maintained copies. The software analogy also makes the testing obligation legible. Before a software deployment, teams run tests. Context deployments need the same discipline. A set of canonical business questions with verified correct answers run against the candidate context repository before it goes to any production agent. If what was Q4 revenue by region returns different values against the test context than it returned last month, that's a failing test, and it should stop the deployment until someone has understood and resolved the discrepancy. The absence of this testing discipline is why context drift is currently invisible in most organizations. There's no test that fails when a glossary term is redefined without propagation. There's no alert when an agent starts routing queries to a different table than it routed them to last month. The access control logs are clean. The failure is silent until a business leader compares two agent outputs and notices the numbers don't match. If this reframe is right, a few things change about how data teams think about their work. The first is that data stewardship gets reframed as AI infrastructure. When a data steward certifies a dataset, assigns an owner, links a glossary term, and writes a current description, they're not doing administrative housekeeping. They're configuring the quality of the AI agent that reads from the catalog. That reframing changes the priority conversation. Governance work that was previously justified on compliance grounds now has a direct line of impact on AI output quality. Teams that have struggled to justify stewardship investment may find the AI agent argument more traceable than the catalog hygiene argument. The second implication is that catalog coverage becomes a measurable proxy for AI governance health. In an organization that can track enrichment coverage, what percentages of its MCP connected assets have current descriptions, certifications, linked glossary terms, and active ownership, has a leading indicator of AI agent reliability. In an organization that can't measure coverage, has no governance signal until agents start disagreeing. That's a lagging indicator. The problem is already in production. The third implication is that multi-agent governance requires architectural discipline, not just procedural discipline. Requiring teams to update their MCP integrations when definitions change is a procedural control. It requires action, it requires awareness, and teams miss it. A single canonical context repository that every agent reads from is an architectural control. It makes the correct behavior automatic and makes divergence structurally impossible rather than merely discouraged. Teams that have adopted this architecture report a qualitative shift. When the definition of a metric changes, they update it once and trust that the change has propagated, rather than auditing each integration to verify the update was applied consistently. The diagnostic question to ask this week: for the assets your MCP connected agents depend on most, the table is your agent's query when answering revenue questions, pipeline questions, customer questions. What's the enrichment coverage? Do those assets have current descriptions? Are they certified? Do they have named owners who are still at the organization? Are their glossary terms linked? If the answer to most of these questions is, I'm not sure, that's the governance gap. Not the OA auth configuration, which is probably fine. The metadata quality, which is the actual determinant of what your agents know. The first decision to make: establish a coverage standard for MCP connected assets before expanding the footprint of your agent deployments. Decide what ready for AI means for a catalog asset: a certification, a description, an owner, at least one linked glossary term, and measured coverage against that standard. Then treat improving that coverage as AI infrastructure work, not catalog maintenance work, because that is what it is: AI infrastructure work. 6 months from now, a team that's adopted this reframe isn't just governing who can call their MCP servers. They're tracking enrichment coverage as a health metric. They have a process for propagating definition changes across every MCP connected agent rather than updating each integration manually. They treat catalog certification as a production deployment decision with downstream AI consequences, not as an administrative checkbox. And when someone asks, why did this agent give a different answer than it gave last month? They have a governance audit trail that can actually answer that question, not just a security log that shows the call succeeded. The goal, though, isn't perfect metadata. Perfect metadata is aspirational and expensive. The goal is metadata that's good enough, maintained well enough, governed consistently enough that your AI agents reason from the same business truth, not from whatever version of that truth each team happens to encode when they set up their integration. The access controls are table stakes. The context quality is the game. Governing MCP is a metadata quality problem, and organizations that treat it as an access control problem will build well-secured AI layers that give confidently wrong answers. But that immediately raises a follow-up question. If catalog enrichment is AI infrastructure, which it is, what does maintaining it at scale actually look like? And how do teams avoid the enrichment backlog becoming a bottleneck as their agent footprint grows? That is what we'll take a look at next.